I did expect that we would see gravitational waves with LIGO in my lifetime. And I thought it quite likely that it would come from two black holes of just the sort that we did see. In fact, I wrote a popular book that is called Black Holes and Time Warps, Einstein's Outrageous Legacy, published in 1994. And I wrote a prologue, the beginning of that book, on my honeymoon in Chile in 1984. And in that prologue, I describe the observation of two black holes, both 25 solar masses, spiraling together and merging and producing 3 solar masses of energy and gravitational waves, and that's very close to what was seen. So I was already in the early 1980s targeting this as the most likely kind of source. So for me, this was not a surprise. It was a great satisfaction that everything had come out the way that I had thought it probably would. So the primary inventor of this kind of gravitational wave detector is Ray Weiss at MIT. He not only conceived the idea in parallel with several other people, but he, unlike anybody else, went in and he identified all of the major sources of noise that would have to be dealt with in the initial detectors, and he invented ways to deal with each of those. He estimated how much noise would remain after the experimenters had done what he proposed to do with each noise source, and concluded that the sensitivity that could be reached would be good enough that there was a real possibility of seeing the waves that I, as a theorist, and my colleagues were predicting. And so he wrote a paper in 1972 describing all this. And that is one of the most powerful papers I've ever read, perhaps the most powerful experiment-related paper. It was Weiss, the inventor of the technique, but I was skeptical until I had long discussions with Weiss and with Vladimir Braginsky in Moscow. I then became convinced and decided that I should devote most of the rest of my career to helping them succeed in gravitational wave detection. We had superb management, particularly with Barry Barish, who transformed LIGO from taking over as director when we were just about ready to begin construction, aided the modern LIGO. And he is an absolutely fantastic project director. And having him lead us through that transition into the modern LIGO was absolutely essential and really is to our success, and was a tremendous contribution to the project. Having leadership like that is, in my experience, it's crucial, and it is the best. Well, that plus some very good experimental ideas and a superb team, but it's an essential component of success. We expect to see neutron stars orbit each other, collide and merge, and that will produce a lot of electromagnetic waves. It is thought to be a source of gamma ray bursts that have already been seen. We will see black holes tear apart, destroy a companion neutron star, again producing a very strong electromagnetic emission, as well as neutrino emission. And so the coordinated gravitational and electromagnetic observations and neutrino observations will be very powerful in figuring out what's going on. If you only had the neutrinos, or you only had the gamma rays, or you only had the gravitational waves, you would get a small part of the information. But with all of them working together in multi-messenger astronomy, there's a great richness of information to be had. So that really is the future of a large portion of this field. I'm quite sure that gravity will be reconciled with the other three forces. I think it's quite likely that this will be done through some version of string theory or M theory that many theorists are now working on. And when that does happen, that resulting laws of quantum gravity will be the tool to analyze questions like the nature of the birth of the universe, whether or not it's possible to build time machines to go backward in time, what is the nature of the interior of a black hole, the singularities inside black holes, and many other interesting questions. So this is a tremendously important effort. It is by far, I think, the most important research direction in theoretical physics today and in recent decades.